Galileo's Tick Tock. Galileo Galilei was an Italian scientist. Let us read about how during his younger days he observed the swing of the pendulum, which later prompted him to discover the laws of the pendulum. It was a wintry morning in Pisa, Italy, in the 16th century. A young student of 17 years sat motionless in the Pisa Cathedral. He looked worried and unhappy, and hardly glanced at the book of Psalms that lay in his hands. He was in a dilemma. He wanted to study mathematics, his first love. His father insisted he study medicine. He had little interest in the subject, although he had already started studying it at the University of Pisa. His father was, indeed, difficult to disobey. As the lad pondered over his problems, his gaze shifted to the high ceiling of the cathedral. Some repair work was being carried out there, and a lantern swung to and fro. He began to watch it with interest as it swung in wide arcs. Suddenly his eyes widened. The arcs were becoming smaller and smaller, but big or small, they seemed to take the same amount of time to swing. It was strange indeed. Galileo, for that was the lad's name, sat up straight in excitement and felt his pulse. Its regular beat was his best timekeeper, and he began to time the lantern's swing. He was right. The lantern always required the same amount of time to complete a swing, no matter how long the range of its swing. Galileo did things thoroughly. He ran home in excitement to try out his own experiments. He fixed one end of a string to a branch of a big tree in his garden. He hung an iron weight from its other end. He now pulled the string back and released it. Galileo thought hard. His experiment confirmed that the time taken for one swing remained the same, regardless of the weight attached. However, the pendulum. This early experiment made him realize later that the pendulum, which was a weight fixed to a rod or cord, could be used to regulate the movements of a clock once it was put in motion. After all, it had the astonishingly useful habit of swinging to and fro at the same speed, according to its length. However, 7 decades passed before a Dutch scientist, Christian Huygens, adopted Galileo's idea to build the first pendulum clock with a regulating movement. Galileo's remarkable discovery ushered in the era of accurate timekeeping. However, the first mechanical clocks had already appeared a few centuries earlier. Although it is difficult to say exactly when, water clocks with moving parts were in use in China 500 years before. Around the 13th century AD, the first mechanical clocks appeared in monasteries in Europe and were operated by monks. They were enormous structures, often weighing 7 tons, and were made by unknown ironsmiths. These early contraptions did not have hands or a dial. They did not even strike the hour. They were used to alert somebody or to toll a bell that called monks to prayer. Their movements were simple and noisy, driven as they were by weights and wheels. Called turret clocks, these first clocks were nearly always placed on church or bell towers, so that everybody could see or at least hear them in the town. They were not of much use when they were out of sight or earshot for those people who wanted to move about and still know the time. However, despite their crude working, they managed to work for many years, although they did not always tell the correct time. The word clock, or clock, as it was called in Middle English, goes back to this time. It was taken from the French word cloche, which means a bell. French was widely spoken by the English upper classes, and many English words were borrowed from it. Bells were therefore associated with clocks in those early days of mechanical timekeeping. In fact, even before mechanical clocks existed, churches and monasteries rang bells to tell the common folk that it was time for prayers. The devout would stop all their activities to say their prayers. Some of these prayers, for which bells were rung, were called sexts and nones. These terms were taken from Latin and meant the 6th hour and the 9th hour when prayers were said. So the ringing of prayer bells also indicated the time. Even when mechanical clocks with dials and hour hands were made, they struck the hours and were used in the same way as prayer bells. So it is little wonder that all timekeepers were called clocks or cloches. The French themselves, strangely enough, call a clock horloge, which has nothing to do with bells, but indicates hours. From the beginning, these clocks were designed to tell the time by dividing the day into 24 equal hours. This was based on the ancient Egyptian time division of 1 day. The hours were further divided into 2 lots of 12 hours each for every day, that is, 12 hours of daytime and 12 hours of night. However, we really do not know why the divisions fell in the middle of the day and the night, falling after noon and after midnight. People had further divided each hour into 60 minutes and each minute into 60 seconds. The figure 60 was probably taken from the ancient Babylonian counting system, which used 60 in much the same way as we use 10. However, the earlier mechanical clocks did not bother about marking smaller divisions for minutes on their dials or using a minute